Sorry about the dog barking, guys. So, we were talking about homologies versus analogies. So, homologies again are going to be those traits that come from from a common ancestor. And those are the ones that are going to allow us to establish evolutionary relationships. Whereas analogous features only let us see that they evolved in a similar environment so that they have similar traits from that. When we look at an analogous relationship, we call it convergent evolution. So convergent evolution is where you take two animals with that originally their ancestors had very different shapes, and then you have them evolve in a similar environment so their shapes will become very similar to each other. So that is convergent evolution, which does not help us establish evolutionary relationships between animals. So we're more interested in homologous features that will allow us to establish those relationships. When we're looking at homologous features, another thing that we want to pay attention to is whether they are ancestral or derived features. So, ancestral features are more primitive. They are features that have changed very little from what the common ancestor had. So that would be like monkeys having a tail. Monkeys have tails because that their common ancestor had a tail. A derived feature is one that has changed significantly from the ancestor, has had more extreme change. An example of that would be the apes and humans don't have a tail. We share a common ancestor with monkeys if you go back far enough, but at some point in evolutionary history, we lost our tail. So that's a derived feature, the fact that we have no tail. It's not something that the common ancestor, we're looking at the common ancestor between us and monkeys having a tail, and all the monkeys have a tail and we don't. So that's a derived feature. When we discuss biological classification, classification is an information retrieval system for us. It orders objects into groups based on similarities to make it easy to understand the overall picture of what we're looking at. Hierarchical systems, which is what we're looking at, which is where you have the bigger one and then the smaller subset, smaller subset, smaller subset. They're sets with subsets. They start off with a large one and they get smaller and smaller. Each lower set shares an increasing number of features in common, of characteristics in common with other members of that set. One of the people who helped to establish this type of hierarchical correlation is a gentleman who was named Carl Linnaeus, Linnaeus. And he came up with the idea of binomial nomenclature. So bi means two, nomial is name. So that's the scientific, what has become the standard scientific method of naming an animal, where you have the genus and the species as the main name. So Homo sapien for humans, Pan troglodytes for chimpanzees. So you have the genus and the species. And that's what how it's done no matter what country you're in. It's always done in Latin. So Latin has become the universal scientific language. So when you do these names, there is a standard naming system for setting them up, and they're always done in Latin. So no matter what country you live in or what language you speak, you can still understand what is being, how these things are being named. And again, page 241 has the thing for the orangutans that shows all the different levels of the hierarchical system for naming the orangutans. So the science of naming organisms one thing we have to deal with is taxonomy. Taxonomy is the identification, description, and naming of the organisms. So if you went out into the jungle and you found a new bird, then you would identify it that it's a new bird, and then you would describe it. And then as if you find a new species of any animal, whether it's a living animal or you found a fossil that it represents a new species, then you as the finder of it get to name it. So then you would name it. Then classification, so that then you get that you are picking the species name. The genus, you then have to use classification to figure out where in the hierarchical group that particular organism that you found fits. Is it its own separate genus, that you found a new genus, or is it a species within an existing genus? So that would be the classification. That's based on the hierarchical groups based on their relationship to other organisms, evolutionary relationships. So then you have systematics, which is the theoretical perspective with which one names and places the organisms. There is disagreement within the scientific community about what aspect of evolutionary history should be emphasized when you are classifying organisms. The first theory of how you should do it is recency of divergence. This is that groups sharing a more recent common ancestor should be placed more closely together. This is when you see evolutionary trees with dates for when they split off from each other. Orangutans diverged roughly 15 million years ago. Humans and apes diverged from each other roughly 7 to 8 million years ago. So humans and apes are, the African apes are closer to each other evolutionarily in this system than they would be to the orangutan because it split off earlier. Other people believe that they should be classified based on the extent to which they have diverged. In that case, humans get in their totally their own group. They're not even classified with the great apes anymore because there's so many changes, because we have become bipedal and all the physical changes involved in becoming bipedal. So those people believe that humans should be in their own group. The first one, recency of divergence, is the more common way of classifying that you will see. So we are kingdom Animalia, class Mammalia, order Primates. There are other mammalian orders besides primates. There's Rodentia, which is rodents, Chiroptera, which is bats, Carnivora, which is the carnivorous animals, Artiodactyla, which are the hoofed animals. So there's a bunch of different orders underneath the overall umbrella of the class Mammalia. The order Primates first evolved from the common mammalian ancestor about 65 million years ago. And if that number sounds familiar, it's because that's about when the dinosaurs died off. So pre-meteor, most of the mammals that you would find on Earth were very small. They were little insectivores, small shrew-like creatures, maybe, this big to like this big. There weren't very big ones because the dinosaurs were in most of the niches. They ate the mammals besides. So once the dinosaurs died, it allowed the mammals to have a vast radiation of evolution into all these different orders and different species, because suddenly all these ecological niches opened up because the dinosaurs were dead. So there was all those areas that they could move into. So you see this vast radiation of new species of mammals occurring around 65 million years ago. And one of those was the rise of primates. So the next question is, what indicates a primate? What makes a primate? And if you look on page 242, there is a list of homologous primate skeletal features. So these are the ones that are actually from a common ancestor that have evolutionary meaning in classifying an animal as a primate. And we're going to need to know these when we move on to fossil primates. How do we know when we get to primates versus just a mammal? When did we get to the order of primates? So the first one that we talk about is the unique ear region. And it's called a petrosal bulla. Petrosal, and the next word is bulla, Bulla. And this is the floor of the middle ear cavity, where in primates, this floor of the ear cavity is formed from a part of the temporal bone called the petrous portion. And that's where the petrosal comes from, is petrous. So you have this unique ear region that other mammals don't have. You have an even more enlarged brain compared to body size. You have an increased emphasis on vision over sense of smell, over olfaction. This increased emphasis in vision shows up as forward-facing eyes, expanded visual centers of the brain. Most primates have color vision. Some have two colors, some have more, but they have, color vision, which not all mammals have. They have a protective ring of bone around the eye, either a postorbital bar, which is just the bone here, or a postorbital enclosure, which when you look in your book, you'll see pictures. The bar is just the bone comes here, but it's open behind the eye. The enclosure means that the bone wraps around the back of your eye to support it. Now, there are going to be openings in the back because you need nerves and blood vessels to come in and out, but it's mostly solid behind the eye, providing more support for its very important part of your body, because we need vision to succeed, to live. Primates need to be able to see because they can't smell as well as other mammals, because we have over evolutionary time emphasized our vision over our sense of smell. Because of this, you also get a shortening of the snout as the sense of sight becomes more important and the smell becomes less important. You don't need as much snout to process all the smells coming in, and a decrease in the size of the olfactory bulbs of the brain. We also have the retention of what's called an unspecialized skeleton. So our skeleton is pretty much what the common ancestor had. Primate skeleton, where you have grasping hands, grasping feet, still have a clavicle, very just ungeneralized skeleton. We don't have hooves, we still have our clavicle. We don't have anything specialized like that. Primates do not have claws on their hands and feet like most mammals. We have nails. All primates have at least some nails. Most of them have nails on all their digits. Some do not, but all have at least some nails. Grasping hind feet with opposable first toes. Grasping hands with opposable thumbs. We have fewer teeth than most mammals. We have 32, humans have 32 teeth. Dogs have 42. Cats have another large number. So we have fewer teeth, and we have the more primitive cusp pattern has been preserved in most primates. What's called the Y5 cusp pattern is a primitive cusp pattern. There's also behavior and life history traits that are specific to primates, but they don't show up as much in the fossil record. But we have longer time of fetal nourishment. So the baby stays in the womb longer and develops in the womb longer than most mammals. Longer interuterine development, prolonged stages of lifespan. So we have primates have a longer, childhood than most mammals. If you look at chimpanzees who the baby is dependent on its mom for several years and will often stay with its mom for up to 6 or 7 years. And then you look at canids like wolves, where the pups generally don't stay with the pack longer, with dependent on the mom longer than about 2 to 3 months. We have a much longer, primates have a much longer developmental period, longer period of infant dependency, more parental care, higher dependence on learning versus instinct. So primates, they don't just instinctively know how to do things. They have to be taught by their parents. If you think about like a foal, the foal is up and running or walking within about an hour after birth. It finds the milk walks over and finds the milk on its mom on its own. And then it, starts chewing on grass without being taught how to do any of that. Primate babies have to be taught how to, where to find food, how to find food. They stay with their moms longer, getting nursed. And most primates live in social groups with communication systems. Not 100%. There are some solitary primates or some that only live in bonded pairs, but most primates live in social groups. So we have gotten down to the order of primates. The next split is suborder, and this is on page 243. There are two main suborders for primates. The first are the Strepsirrhini, and the Strepsirrhini are the most primitive appearing of the primates. They have many ancestral or primitive features. Some of these they have a tapetum lucidum. This is the layer in the back of their eye. If you've ever shown a light out at night and like your cat's eyes light up at night, green, that's the light shining off the tapetum lucidum, which reflects light into the eye to help them see at night. So most of these guys, not all, but most of these are going to be nocturnal. They only have a postorbital bar, not a postorbital enclosure. Remember when we talked about skull sutures, and I mentioned the metopic suture, which is in the frontal bone in fetuses, in humans. In these guys, in the Strepsirrhini, the metopic suture stays throughout their life. So they always have that. They also have a mandibular symphysis. The jaw is in two pieces. And then these guys have two unique derived features. One is what's called a tooth comb. And that is that their incisors, their lower incisors, are all the same length and the same shape. And if instead of being upright like this, they kind of go out like this. And there's a picture of this on page 243. The tooth comb is used for grooming. It is used as a comb. They'll run those teeth through their fur to help groom their fur. The other is their grooming claw. So here are the primates that still have a claw on either back foot. So the second digit of the foot has a claw on it. Again, it's used for grooming, for running through their fur. Okay, it's a grooming claw. These guys also have a moist nose like a dog with a split in the nose and down into the lip. And there is a picture of this on page 243. There's two columns on 243 that show you the two suborders and the differences between the two. So those are the main things for the Strepsirrhini. Then the Strepsirini can be split again into two infraorders. So infra is the next one below suborder. That's the Lemuridia and the Lorisoidea. So Lemuroidea are the lemurs and the aye-ayes. And lemurs and aye-ayes are all found on the island of Madagascar. And we're going to go into some of these types of primates more in the next class, in the next chapter. So we're just kind of mentioning them to start with now, and then we'll go into more in-depth view of the animals themselves next week. So lemurs and aye-ayes are their Lemuroidea, and they're all found in Madagascar. And the Lorisoidea are the lorises, the galagos, and the patos, and they are found in both Asia and Africa. So the other suborder are the Haplorini. Haplorini do not have a split in their nose. Their noses are dry. And they have much more changes, much more derived features, and less in common with the common ancestor. They don't have a tapetum lucidum. They don't have a tooth comb. They don't have a metopic suture during their entire life. It fuses in infancy. So things like that. They have no claws at all. They're all nails. There are 3 infraorders found in the haplorines. Tarsiforms, which are tarsiers, the Platyrrhini, which are the New World monkeys, and the Catarrhini, which are the Old World monkeys, apes, and humans. Tarsiers have a lot of similarities with both strepsirrhines and haplorhines. At one point, they used to be classified in this old order called Prosimiae, where they were lumped actually in with the lemurs and the lorises. But further research has now placed them in with the haplorhines instead, even though they have some features in common with the strepsirrhines. There's only one genus of tarsiers. There's several different species, but there's only one genus. They are nocturnal, but because they do not have a tapetum lucidum, they have huge, huge eyes. And their eyes are actually bigger than their brains. Their eyes have to be so huge to make up for the lack of tapetum lucidum. Like the strepsirrhines, they do have an unfused mandible, and they do have a grooming claw, but they do not have a tooth comb. So they have features in common with both groups. Are kind of like an intermediary form between the strepsirrhines and the haplorhines. And because they're insectivores, their molars have very sharp, pointy cusps. Then you have the Platyrrhini. Platyrrhini means broad-nosed. These are the New World monkeys. They split off from the Old World monkeys, from the monkeys in Africa about 35 million years ago. And they're only found in South and Central America. That's why they're considered New World monkeys, because at one point the scientific community split. The Old World was Europe and Africa, and the New World was the Americas. So these are the New World monkeys. They have side-facing nostrils rather we have downward, or gorillas have more of a pushed-up nose, so they're very forward-facing nostrils. Their nostrils actually point off to the side. They have no bony ear tube. And some of them have prehensile tails. These are the only monkeys with prehensile tails. So the difference in their nose shape and the prehensile tails and the lack of a bony ear tube are all derived features that occurred after they split off from the Old World monkeys. They also have a different dental formula. So their dental formula is 2-1-3-3. So they have in each quadrant 2 incisors, 1 canine, 3 premolars and 3 molars. Then we have the Catarrhini. Catarrhini, again, they have either downward facing nostrils or forward facing nostrils. The Catarrhini are more closely related to each other than to any other primate. This is the most cohesive group in terms of relationship to each other. Now, old world monkeys, apes, and humans. Their dental formula is 2-1-2-3. So they all have the same dental formula that we have, and they do have a bony ear tube. Now we split it down even farther. There are 2 superfamilies, which is the next level down. So Cercopithecoidea are the old world monkeys. So the old world monkeys all have a tail. They have a narrow thorax, so their chest, it viewed from the front, side to side, is narrow. And they have what's called bilophodont molars. And there is a picture of their molars in your book, so you can see on page 246 what a bilophodont molar looks like. But basically, bi again is 2, and a loph is when the cusps kind of fuse together to make a ridge. So it only has, instead of 5 cusps like we have, they just have 2 ridges on their molars. And then the other superfamily is Hominoidea. That's the apes and humans. So this is the Hominoidea has the largest relative brain size. We have the Y5 molar pattern, which we'll discuss more in another class. We have a broader thorax, so our chests are broader, and we have no tail. All right. So it's important to keep track of teeth when we're talking about all these different animals, and when we do bring up teeth shape and Y5 pattern, bilophodont molars, because teeth are often the only thing found in the fossil record. They last the longest because the enamel is so hard, it protects them, and they last best. So often you are identifying which of these, whether it's a Cercopithecoidea or whether it's a Hominoidea, based on, if it's a fossil, based on just their teeth shape. On page 246, there is an overview of primate classification that you can use to help you understand what we've been talking about. The last thing we're going to talk about just briefly is cladistics and evolutionary taxonomy. I don't go into this very much in depth because it's something that some people use one form, some people use another. If you stay in anthropology, you'll learn more about it in your subsequent classes. The difference is one form uses recency of divergence, and one form uses the degree of evolutionary change. So the newer approach, which is called cladistics, uses recency of divergence. And this puts apes and humans closer together than orangs because of when they diverged. Cladistics shows evolutionary relationships. It highlights the branching patterns that demonstrate the taxa that shared ancestry more recently versus longer ago. But it does not include a time factor of when they split off from each other. And it does not specify any ancestor-descendant relationships. And there's an example of a cladogram in your book on page 249. So what you have with the cladogram is you have the clade is the evolutionary lineage, and the node is the branching point. So if you're looking at this picture, what they're showing you is each one of these. So you have 1, animal 2, animal 3, animal 4, animal 5. X is a trait that all of these animals have. B will it be a trait that only 3, 4, and 5 have? A is a trait that only 4 and 5 will have. So it's showing how they split off from each other. The other way of showing this is called evolutionary taxonomy or systematics. And that uses trees to show ancestor-descendant relationships. And that one is the one that talks about how long ago they branched and how long each species has occurred. So in that case, here's an evolutionary tree. 13 million years ago, orangutans split off from the common ancestor down here. And then 9 million years ago, the gorillas split off. And then 6 million years ago, chimpanzees split off. And then 2 million years ago, the bonobo chimpanzees split off from the regular chimpanzees. And that last split was when the chimps split from the humans. And that's the human line. So that's what an evolutionary tree looks like. So which one you use would depend on what you're trying to show and what your teacher expects you to know in a class where if you're writing out evolutionary trees. The more recent one is the cladistics, the more older, more traditional one is the evolutionary trees. So that is chapter 9. Your homework will be posted for this week on Monday, obviously. And if you have any questions, again, always feel free to ask me. And I will see you again next week. Bye.